Hi. Uh, so I'm just waiting for a few more folks to join. So let's wait for a few minutes. Team, could you just check if the audio, everything is all right? Okay, this is a mic check just to ensure that everything is working okay. This is a mic check to ensure everything is okay. Uh, okay. Okay, this is a mic check just to ensure that everything is okay. I hope nobody has major issues. So I'm just looking at the comments as we go. We'll start the session in a couple of minutes, just waiting to see. Uh, okay, audio is good. I hope the video is also doing good. Uh, okay, so, okay, let's wait as people join in. Okay. Hey, folks. Hi. And yeah, welcome here. I'm just waiting for a couple of minutes, giving people time to join in because the clock just ticked 7. So just giving a few minutes here. Yeah. So let's wait for, I think we have about 242 viewers right now. Just waiting because the more users who I think have subscribed for this. So just waiting for them to join in. Okay. Give us a couple of minutes. Any mic issues? Okay. Thankfully, everything seems to be working well, which is always good. This is the first YouTube live session that we're doing. So this is new to us. We were very concerned about hiccups and things like that. So yeah, somebody was suggesting to have some of these live sessions over weekend. We'll surely try that. Yeah, I'll come to what productionization of a machine learning model is and all of that. So the topic is, as the live session says, is everybody able to hear me? Does anyone have issues? Team, can you hear me? Okay, so uh, just try to increase the volume on your box because it seems most people have most people can hear us. So okay, so we'll answer some of these general questions that I see flowing in. Just one more minute at 7:02 sharp, we'll get started. Right? So just give me a minute or so. Okay, so okay, just waiting for a minute more. I'll just take a sip of water before we get started because we have a long session in front of us. Okay, folks, just in the interest of time, let's get started now. For those of you who may not know me, you might have heard my voice on other YouTube videos or in the course. My name is Srikanth Verma Chekuri. I'm one of the instructors at Applied AICourse. And the theme of this live session is the productionization and deployment of machine learning models, right? So like all the traditional videos you see, I'll take myself off this video and actually put up content. We'll go through some of the challenges, issues, and things like that. Just as an organization philosophy, we thought to make this conversation fun and interesting and also knowledgeable for all the participants. We thought we would go over the content for about 60 minutes, how much ever we can cover, right? This is mostly about how to productionize and how to deploy a machine learning model or a deep learning model into production. And what are the challenges? What are the design choices that we have? Right? So we have discussed some of this in the course, but I wanted to go into some more details here, show you some examples, some nice references and things like that. Having said that, the whole session itself is 90 minutes. So we would spend the first 60 minutes to cover some of the interesting concepts, how much ever we can cover. If you cannot cover this, probably we can do whatever I could not cover in the 60 minutes, we will do one more live session soon. So we can do some of these. In the last 30 minutes, please leave any questions related to this session. Okay, we would try and answer the most frequently asked questions in the last 30 minutes. Okay, my team is collating all of these questions and they'll put up the most frequently asked and the most interesting questions, and we'll try to answer as many as possible in the 30-minute window. Right? So let's get started now. We're already 3 minutes. So I hope you understood the way we're trying to do this. 60 minutes of content. And put in your questions, as in when you encounter something, please put in your question. We will try to take a few questions, how many ever we can answer in the last 30 minutes. We'll try to answer all of the most interesting questions or the most frequently asked questions in this session. Okay. Having said that, let's get going. So I'll start sharing my screen because that's just easier. And I'll take myself away and I'll focus more on the content as we always do at Applied AICourse. Just give me a second. Okay, I think we are good to go. I hope everybody can see my screen now. I'm just testing it. Give me a second. Present to everyone. Okay, so I hope everybody can see me. Just a couple of issues. Okay. Okay, so my team is also collating some of the challenges and questions here. So let's focus more on the content now. Okay. So I hope there are no issues here. Team, any issues? Is the live session going well? Hopefully. You might see some small delays because this is a live session on the internet. So I'm taking myself off of the whole thing. You don't have to, let's focus more on the content, right? So again, just as a quick recap, we will spend the first 60 minutes on the content. On this topic, we will discuss multiple aspects of this. We'll discuss multiple challenges and design choices we have as far as productionization and deployment of machine learning models is concerned. And please leave your questions in the chat window on the right-hand side. In the 30 minutes, after the 60 minutes, we will do a Q&A session, right? We'll try to answer. So my team is looking through all the comments and putting up a few good or the most interesting and the most fun and the most frequently asked questions. I'll try to answer as many as possible in the 30 minutes. Okay, having said this, let's dive in now. So let's assume, so at what stage are you here right now? So imagine you have already trained, let's assume you have already trained some machine learning models, right? You have done a lot of feature engineering, right? Let's assume you have already done this. You've done a lot of feature engineering, right? You've finished all of this and you've built a very nice model, right? Let's assume you've done all of these. You've done everything that is required. You've tried various machine learning models. Now let's assume you have a model M. It could be any model. It could be a logistic regression, an SVM, any of these models, right? Let's assume you have a model M, which again, all of this you've done through an experimentation platform of sorts. So all the feature engineering, you've tried lots of features. Some of them worked out, some of them did not work out. You've tried various machine learning models. Finally, you converge to a model. Now, so you've already performed all of the training, all the evaluation. So you've also done model evaluation, right? Whatever your metric is. So now finally you have a model M. The next big question here is, how do I now take this model? How do I productionize this model? So what does productionization basically mean? It basically means, see, whatever you have done here, this is all the experiments that you have conducted, right? You've taken some data, you've trained some models, you've done some exploratory data analysis, you've done a lot of feature engineering. Finally, you have a good model that you discuss with all of your business folks, all of your managers, and they say, yes, this model meets the requirements that we have. And this model is performing pretty well. The next question is, they say, okay, it is very good. Good job, my friend. Now let's productionize it, which means you want to deploy this. In other words, you want to deploy this into a production system, into the real world, right? Whatever you have done is experimentation. Probably you have done this in an IPython notebook, right? If some of you use R, probably you did it in an R studio, right? Whatever it is. In our course, we focus a lot on IPython notebook. So you've done all of this, you've presented your results, everything is good. But at the end of it, you need to productionize this model. You need to deploy this model to the real world. So this needs to be a real world model, right? You need to deploy this model into production at some point. Now, how do you do that? What are the challenges, right? So when you're trying to deploy a model or productionize a model, there are a bunch of challenges that you will come across. What are the challenges? What are the options you have, right? What are the choices? What are the design choices that you have? Okay, what are the design choices that you have when you're productionizing these models, right? Very important and interesting. We have very important part. So this is one aspect that we have covered partly in the course, but not completely. So we have covered this. We have covered this partly in the course, but not very deeply, right? So I wanted to go over some design choices here in this video, and see and shed some light on the challenges that are there, options that we have, and the design choices we have. I'll also explain a few interesting options, right? So let's go into this. So what does the whole data science life cycle look like? Right? If you think about it, you basically have your raw data. Right? If you think about it, you have your raw data. Now, this raw data could be present in various forms. This raw data could be present in a CSV file. Very good. Or it could be in some other text file. Right? It would not be a comma separated value file. It could be any text file, a tab separated or whatever. It could be a CSV file or a text file or a database. Okay, or a data warehouse, right? It could even be specialized databases like Hive, right? It could be a Hadoop. This data could be on a Hadoop distributed storage, or it could be Spark storage, right? So all of them are places where your raw data may be sitting in. If you notice in the course, we have covered extensively CSV files. We have covered other forms of text files, right? We have also introduced this whole thing called SQL more recently to the course. So if you're using any modern database or a data warehouse, or even platforms like Hive and Spark, most of them provide either SQL as a way to obtain the data, right? So we have added this whole section called SQL because we felt this was a missing piece in the course earlier, right? So SQL is a very nice way to obtain data from databases, data warehouses, Hive, Hadoop, or Spark. Most of them have either SQL or a variation of SQL, right? Like for example, Hive has something called as Hive query language. Spark has something called as Spark SQL. These are mostly built on top of SQL. Like Oracle databases has something called PL/SQL, but most of them are based around SQL. So if you know SQL, you will be able to obtain data from databases, data warehouses, Hive, most Hadoop, most data on Hadoop and Spark, right? So this is where your raw data is. Your raw data could be stored anywhere here. That's important to appreciate. So these are all the choices, as I told you, right? These are all the options and choices where your data could be present. Wherever it is present, the next step is you take all of this data and you process this data. You process this data to obtain finally your featureized data, right? So for example, during the experimentation stage, right, this is your final featureized data, right? In your experimentation stage, okay, where you're experimenting with all of this various feature engineerings, EDA, all of that, you would have said, these are the features that are working best for me, and I'll use these features in my model M, right? You would have figured that out. So finally, we want to process all of this raw data and obtain the featureized data. Now, how do you achieve that? Your data could be lying anywhere here, right? So there are multiple tools that you can use. Of course, SQL is one big tool, because using SQL, you can read the data in databases, warehouses, Hive, Hadoop, Spark, etc. In addition to that, you might use one of these programming languages like Python, Java, whatever you want, R, whatever, right? Because when if you're following our course, right, some what we do is we use IPython notebooks, wherein some of the featureizations are done in Python. We use various libraries in Python, like pandas, all of these things, right, to featureize some of the data that we want, right? So typically you have SQL to obtain the data, Python to process the data, right? Or any programming language. This could be in Java, this could be in Scala, this could be in R, whatever you want, right? Of course, Python is again one of the most popular languages here, but this whole processing stage, right, is often referred to as ETL stage. I'll come to what ETL means, right? This whole stage is called ETL. Okay, so what you're building here is a data processing pipeline, right? This whole thing, whatever you're building from raw data to featureized data, you're basically processing all of the raw data to get featureized data. This is called the data pipeline. Okay, this is typically performed again depending on the team. So there is a whole role called data engineers. not data scientists, not machine learning engineers. In most companies, there is a role called data engineers who are experts at your data warehouses, databases, Hadoop, Spark, all of these things. And they're also experts at most of these things. So given raw data, probably when you're experimenting, imagine if you're a machine learning scientist or a machine learning engineer or a data scientist, right? Right? You may not be very comfortable with all of them. So typically in a large company, you typically work with data engineers who are experts at this ETL pipeline, right? Who are experts at obtaining the featureized data from raw data. Of course, they may not know some of your featureizations. Suppose if you're doing some Fourier transform, the data engineers may not know what Fourier transform is. So you have to work with data engineers very often in the data pre-processing or the data pipeline part. Of course, if you're working in a small team, you do not have the pleasure of having specialized data engineers. In such a case, it's a data scientist who end up building this. Of course, they may not be as good as data engineers, but you can build this if you know decent amount of SQL and one of these programming languages, right? Now, so what is ETL? So let's go to Wikipedia and find out what ETL stands for, right? ETL stands for extract, transform, and load. Okay, if you look at it, imagine if I have a database. This could be a database, this could be a data warehouse or a Hadoop data storage, whatever it is, right? What I'm performing as part of my data processing stage is nothing but ETL. I'm extracting the data, right? I'm transforming the data and I'm loading the data for further processing. Right? This is a Wikipedia page. As most of you know, we use Wikipedia pages extensively and all the open resources extensively. So this is the page for extract, load, transform on Wikipedia, right? Again, most of the times it's done using your SQL and other. Of course, there are some specialized pipelines, etc. But in a nutshell, what this does is it's basically loading the data from various. It's basically extracting, transforming, and loading. Right? That's what this is called, the ETL pipeline. This is also referred to as the data pipeline. Right? Of course, here there are lots of design choices. When you productionize it, you might either work with data engineers, or if your team is not big enough, it's a data scientist who have to do it. Now here there are lots of choices. How do we pick? Right? Everywhere, as I told you, when you're productionizing your models, there are multiple challenges and options and design choices in the real world. So now here there are some very interesting questions. Is your data, is the original data in CSV file? Is it in a text file? Depending on where the data is, right? If it's a CSV or text file, you don't need SQL on top of it. You can just do it using Python and Pandas, right? If the data is in a database, you got to use SQL because that's the easiest way to obtain this data. So designing this pipeline, right? If you're not an expert, will take some time. There will be errors. Of course, when you're designing this, you need to ensure there's another interesting challenge here, which is how often do you process this data? What is the frequency? What is the frequency of running this ETL pipeline? Right? Do you run this pipeline every day? Because that depends on how often is your raw data being generated. Imagine this is some sales data. Imagine this is some sales data at an e-commerce company, right? You would get data very, very fast. Every hour there is new sales data, right? Every day there is new sales data, right? So how fast or how often you have to process, how frequently do you have to run this ETL pipeline? Because that depends on how often you want to train also. Look at it. So what do? You take this featureized data and train a model M on top of it, right? There's some more stages here that I'll come to, right? So you're basically, so if you want to retrain your model on daily basis, you have to run this ETL pipeline on daily basis, right? So there are a lot of these design challenges, especially if you're sitting on large amounts of data. Imagine if you're an internet company that is generating petabytes of data, like Twitter, Google, Facebook, Amazon, etc., Flipkart, right? Then you might want to run this pipeline much more frequently. You might want to run this every 1 hour. This frequency of ETL pipeline basically refers to how often you want to run this pipeline. That's a design choice that you have to, again, all these are, what I'm giving you here are design choices. What you would use depends on the context. If you're working at a top-notch company with petabytes of data, you might want to run this ETL pipeline every hour. Well, if the amount of data, if you want to retrain this model only daily or weekly, and if the data is not too much, then you might not want to run this whole pipeline every day or every hour, right? So these are design choices. So what I'm discussing here is not the exact solution to an exact problem, but I'm telling you what all choices we have in the real world, right? Especially if you have large amounts of data, like petabyte scale data sets, you should go for Spark or Hadoop or specialized data warehouses. Obviously, you cannot store like petabyte scale data sets in CSVs or text files. Even most databases do not scale to petabyte scale data sets. There are exceptions, of course, right? So there are all these choices. Of course, SQL is a very, very popular choice in ETL. Most teams that I know of use SQL or a similar language, right? Now let's move on to, once you have the featureized data, what are the next steps? These are all the choices and options that we have, as I've been telling you, right? So now let's assume we have the featureized data. So we have discussed what is the data pipeline. So now we have the featureized data. Now, once I have the featureized data, I want to train a model, right? I want to train a model. Because during my experimentation stage, suppose let's assume I figured out that logistic regression. I figured out that logistic regression model was working pretty good for the task that I have. Let's assume this is a logistic regression model. Very good. Now your challenge is take the featureized data and train your logistic regression model. I'll use LR for short, right? I'm trying to train a logistic regression model. Again, there will be challenges here. Let's write down what are the challenges, right? The amount of data, the volume of data, right? How much data you have, right? And of course, there will be challenges here again. And does your model improve as the amount of data that you're sending it into training improve, right? Here you need to do one analysis, which is like this. Sorry. Let me just change this color. So there is some interesting analysis that you can perform here, which is on x-axis, you can say the volume or the size of data. Let's assume you trained your model with 100K points, with 200K points, with 300K points, so on and so forth, right? And this is the performance metric, whatever your performance metric is, right? This is your performance metric. If you notice, see, as the data falls, as the data becomes too small, right? As the amount of data or the size of data on which your model is being trained, if it is too small, right? If the data set is too small, obviously you'll not have very good performance metric. Of course, it is obvious that as the data set size increases, your model's performance also will improve. But beyond a point, it may not improve much. This is what will typically happen, right? If you've trained your model carefully, which means beyond 300,000 points here, there is no reason to use 400,000 points or 500,000 points because the model is not improving significantly, right? So instead of worrying about training, suppose you might have, let's say, 1 billion data points, or let's say 10 million data points. You could have 10 million data points. But in your experimentation stage, you also need to analyze this, which is, as the size of the data increases, does my performance metric also continue to increase, and where does it plateau off? Right here, it's plateauing off, which means there is no significant improvement in the performance of the model beyond a certain threshold. Right? Beyond a certain threshold of 300,000 points, the model's performance is not improving much. In such a case, why should I train on 10 million data points? I could simply sample carefully and just train on my 300K points. Right? This is again something that you need to figure out during the experimentation stage. On the other hand, imagine if your model was behaving like this. Where the model performance is improving as you keep going on. So if you have small amount of data, again, there are three choices here, right? If you have small amount of data, which can most likely fit in the RAM of a box, right? That's a simple. By small amount, what I mean is, if you have a 32 GB box, does your data set fit in the RAM of the box, right? If you have small amount of data set, you could use things like scikit-learn or RStudio. If you're a fan of R, right? Of course, some people use R, some people use Python, scikit-learn, or if you're doing a boosting thing, you can use XGBoost. All of these libraries, because if your data set size is small, why not just use the ones that are simple? But the next question is, what if your data set size is medium to large? Okay, there are three options here. Okay, so you have small data set, which is very good. You can just use the standard library. Some of them we have discussed in the course, like scikit-learn, XGBoost, etc. If you're a fan of R, there is always R Studio, a very interesting and good platform. If your data set size is medium, which means your data does not fit in RAM, but it fits in your hard disk drive or solid state drive, right? Then, of course, some of these libraries will work, but you might want to do some sampling. But again, because of sampling, your performance could drop, right? So in our course, we have discussed some strategies. If the data set size is medium, what all strategies that we can employ. For example, I'll give you a simple example. If you're training a logistic regression model, right? You can load, let's assume this is your total data. You break it up into parts. You train a logistic regression model 1 on this part of the data. You load this into RAM, train a model. You load this, train the second model. You train this, you load this data into RAM, right? So this whole data doesn't fit into RAM, but just this part of data can fit into RAM. Right? So you train 3 logistic regression models and perform some form of aggregation or weight averaging, right? You can just simply, a simple scheme is averaging these 3 models weights, right? And this you can do it on a single box. Even the medium data set, you can do it on a single box like this. Of course, this may not scale to every method, but for simple things like logistic regression, you can train one model. Let's assume my total data is, let's say, 96 GB. There is 32 GB here, and my RAM is, let's say, 32 GB or 64 GB. I train this whole thing first. Then I train the second model on the next 32 GB of data. My third model also on 32 GB of data. And then I average all the models to get the final model. Of course, sampling may not always work, but there are some hacks like this that you can employ. The real challenge comes in when you have large amounts of data. Okay, imagine you need to train your model on, let's say, some 10 million points or even 100 million points, right? Or even a billion points sometimes, because when you're plotting this performance is continuously going up. This performance metric, right, is going up as you're increasing the size of the data, which means there is certainly value in training on large amounts of data, right? So if your instance, or if the problem that you're solving falls in this large scale machine learning models, where the data will not fit even in a single hard disk. Let's assume the data is, let's say, 1 terabyte, or maybe 10 terabytes, or even 100 terabytes, or 1 petabyte. There are very few companies which operate at petabyte scale, but you do see 10 terabyte scale data sets which do not fit on a box. Then what do? Then the best tool that I know of, again, this is my personal preference, there are many choices here. One of the best tools I know is called the Spark ML. Okay, for those of you who don't know, Spark is a distributed system platform. So I'll not go into the internals of Spark, but I'll give you a brief overview of what Spark is. Spark is a distributed computing platform. In a nutshell, what it does is, if you have multiple boxes, let's assume I have these 10 boxes like this, okay? All of them, each box has its own processor, so each box has its own CPU, it has its own RAM, it has its own hard disk drive or solid state drive. Each of these is an individual box. Now, if all of these boxes are connected, through a network in a same physical location, so this is box 1, box 2, box 3, box 10, right? Each of these are individual boxes. Now, your data set, your whole, let's say, 10 terabyte data set doesn't fit on one box, but you could split it into 10 boxes, right? So this data set would actually reside in the hard disk drive in a distributed fashion. That's why this is called the distributed computing platform, right? So your data is split across all of this, your 10 terabytes of data. Is split across all of these hard disks, and Spark is application that runs on each of these, and it will coordinate training of your models and transfer of data across all of them. So if some data needs to be transferred from box 1 to box 3, it will go through the network. And this is your very fast LAN network. All of you might know about LAN, right? Local area network, right? So one thing that works very well here is all of these are connected over LAN, and data transfer could happen from one box to the other box. So Spark is a platform that enables all of this to be done very well, very smoothly, brilliantly it does it. Right? That's the power of Spark. Now, I don't want to go into internals because Spark is a brilliant platform. But if you're a machine learning engineer, right? So as I was referring to earlier, Spark has this thing called Spark MLlib. So let me just scroll down. So this is the documentation of Spark, right? This is the Apache Spark. So if you just Google search for Apache Spark machine learning library, it is called the Spark MLlib. Very, very, I mean, this is one of the best distributed system machine learning libraries that I have seen. And the best part about it is you don't have to be an expert in Spark to be able to use the machine learning library, because understanding the internals of Spark is pretty intense. Okay, there are a lot of distributed systems, operating systems, databases, networking concepts that go into Spark. But without knowing all of the internals of that, right, you could still write MLlib code. Remember, in the course, if you remember, in the course we use TensorFlow, right? So we could write TensorFlow code without knowing the details of GPU programming, right? GPU programming is a very, very exciting area. Without knowing the internals of how GPUs work, without knowing the internals of GPU programming extensively, we could still train models using TensorFlow. Exactly the same way, without knowing the internals of Spark, we can still write MLlib. Of course, if you have time, I strongly recommend you learn Spark. It's a beautiful platform. I thoroughly enjoyed seeing the birth and the expansion of Spark itself. Because when I was a machine learning engineer, when I was a research engineer at Yahoo, Spark wasn't there. We used to do most of this stuff in Hadoop. Now, after Spark MLlib came into existence, things have improved a lot. For example, you could go to this classification and regression here. I'll show you some simple code snippet to show you how simple this is. Right? If you just click on the classification and regression, it will take you to this page. Right? Within this page, you have all the major classification techniques here. Look at this. You have your logistic regression, your decision trees, your random forest, your gradient boosted decision trees, multi-layered perceptrons, your linear support vector machines, your naive Bayes. Most of these techniques are implemented. So if you know R or if you know sklearn, right, picking up some of these things that are there in Spark is very simple. It's not at all a rocket science. The MLlib in Spark is extremely easy. I've seen people who are not software engineers pick it up over a weekend. To be honest, it's that simple. I'll show you how simple it is. So if I click on binomial logistic regression here, what I get is this page, right? So if you go here, this is the page for binomial logistic regression. There is some documentation. The beautiful thing with Spark is I can write code in Scala. Those of you who don't know Scala, don't worry. You can write code in Java, Python, or R. My favorite is obviously Python, but I've had some colleagues who wrote brilliant code in Scala. In Python, it's literally very, very simple code. I'll show you, right? Imagine I have data in some data set, in some text file, right? I just have to say spark.read. So this data is in some specialized format. So I say spark.read, right? This is my Spark, right? I can easily import Spark by saying pyspark.ml. PySpark means Spark in Python, because whole of Spark is actually implemented in Scala, not in Python. Okay, so I can say from pyspark.ml classification, import logistic regression. Very straightforward there. Now here in this line of code, I'm not going into the depths of it. In this line of code, I'm basically loading data from this text file. Okay, and this data in the text file is in this specific format. So I'm saying spark.read.format. I'm saying in this format, load this file. This looks very much like a pandas. If you think about this, this looks very much like a pandas interface. Right? You may not be an expert in Spark, but you can still write this code very easily. Now here I'm in the next line, I'm defining a logistic regression model. I'm saying I want to do only maximum of 10 iterations. This is my regularization parameter, and this is my elastic net regularization parameter. Right? We discussed all of them in the course in a lot of details. So here I'm defining an object, right? Which has this, using which I can actually train a logistic regression model. Training the model is literally one line of code as always. Just like if you look at it, this is very similar to scikit-learn. Right? All I'm saying here is I'm using this LR and I'm saying dot fit. And what do I fit this model? This model has these three parameters. And what is the training data? This is the training. because we loaded this data into training, right? That's it. You fit a model and you can print the coefficients and the intercept, basically your weight vector, your W and B of the logistic regression. It's that simple. Literally in 5 lines of code, you have done a Spark ML logistic regression model. It's that simple. If you know, again, there is also, for those of you who know R, there is also you can also write very simple code in R. If you're a fan of Java or Scala, the code is very, very simple, right? Very, very elegant. So if you have an instance where you have 10 terabytes or anything which doesn't fit into your hard disk, Spark ML is a good choice, and it's extremely easy. You need not know the internals of Spark, but you can still write some beautiful code, just like the way, without knowing lots of internals about GPUs, how they work in GPU programming, we could still use TensorFlow, right? So if you come across an instance where you have multiple terabytes of data or even petabytes of data, right? So this training, if it is small, just use the simple stuff. Medium, do some of these hacks. Large, if your data set is medium, you can still, I mean, if you have the resources, you can always go and use Spark. Now, the next logical question here is, this Spark is a distributed system platform. The whole Spark cluster, because you have 10 boxes, right? This is called a cluster of boxes. This is called the Spark cluster. This is called the Spark cluster. Typically, these Spark clusters are maintained by data engineers, right? Of course, if you're working in a startup or a small team, you may not have specialized data engineers. So sometimes you might have to install Spark, but there is very beautiful documentation on installing Spark. But again, trust me, this is non-trivial. It requires a lot of effort and optimization that you need to put in, right? If your company or team requires to use distributed computing in the long run, it makes complete sense to suggest to your managers and leadership to have data engineers on board, so that both these things, right? So that all of your cluster part as well as your raw data to featureized data parts can be taken care by them. Sometimes, of course, when your team is small, you have to do some of this dirty work. It's fun, actually. I would call it fun work, but again, this is not core machine learning itself. Okay, so now you have trained your model. Life is good. What next? You have trained your model either in one of these libraries or using some hacks, or if you have large amount of data, using Spark. Now what next? So this is all productionization of models, right? This whole steps you have to go through in productionization. Now you want to deploy the model into production. That's a fun challenge. Now you have a model. Let's assume you have a model M. Okay, this model could be presented. I'm sorry. This model could be present in multiple forms. This could be a Python. This could be a Python object if you're using Python, or it could be a Java object. Or you could get, suppose if this is a logistic regression model, you could obtain the parameters of the model, like the weights and the bias terms, right? You could get weight and the W and B if you're using a logistic. Let's assume this is a logistic regression. You can get a Python object, right? A persistent Python object, right? So a persistent Python object, which means you can take this model file, you can take this Python object and store it to disk. By persistent, I mean you can store it to a hard disk or a solid state drive, or you can obtain this W and B. There are two options here. How do you store so you can store this to your disk or a file, right? This is one option you have. There are two options again here. One is take the parameters and store it to a file, or if it's a Python object, you can also persist it. And we have discussed some of these things in detail in the course also. Okay, how to persist it and all of that stuff. Now, so you have your model stored on disk finally. Okay, now you want to deploy it. So what does deployment mean? Okay, and let's understand how does it work. So you have stored this to the disk. Suppose there is this box. Let's take a single box instance for simplicity. So there is this box 1. Okay, this is your box. You trained the model, right? You stored the model in your hard disk. Let's assume this is your hard disk drive. You have your CPU and you have your RAM. 3 major components of any box, right? Your model is now stored in a file. Your model is stored here. Now, deployment basically means how does the model that you've built interact with the rest of the software that your company is writing or your team is writing. Let's take a simple example, right? Imagine imagine a world where you're building a big software. Again, there are some software engineering concepts which are very basic. Like GPU programming is a full-fledged course at some universities. So I cannot go into too depth. Like software engineering and software architectures is a multi-semester course, right? So typically what happens is this. This is one of the possibilities. I'm not saying this is the only possibility. Let's assume here is a server. Let's assume here is a server. Let's take an internet example so that it's better. Now, let's say I have a, let's assume I'm a user. Okay, I open up my browser. Okay, let's assume I open up my browser and I type in some Amazon.com or whatever. Right. So now, what happens if? So this goes to an Amazon server. Right. The Amazon server will again call other. The Amazon server would be connected to a database. And just a second, folks, just a second. I'm seeing, I believe some of you have some voice issues. Just a second, folks, just a second, please. Is this problem persistent? Because one of my teammates was just informing me that some of you have voice issues. Is this persistent? Okay, I'm just going to the, okay, the voice is breaking. What started breaking? The video is not good to follow. Okay. Is this better enough? I have a fairly good internet connection out here. Yeah, there is certainly some lag. We tested it thoroughly in the morning also, but there is certainly some lag here. Okay, let me adjust my microphone a little more. 1 second. Just a second. Is this better now? Okay, I'm just pulling the microphone very close to me. Just a second. This will hinder some of the content, but let's see. Just a second. Okay. I'm just bringing the microphone much closer to see how well this works. Is this better by any chance? Let me start screen sharing again. Okay. Okay, I think there was a small hiccup earlier. Sorry for that. And yeah, so let's get back to where we were, right? Okay, this is good. So I've just pulled the microphone closer to myself. So let's go to the software architecture parts again. So you have a browser here, you have a server here, and you have multiple instances. And so the server might call, and this is, so if you're going to a web server, right? The web server has to load the page at the end of the day. There might be one module here, for example, it might want to predict, let's say, it might want to, suppose this is, let's say, Amazon page, right? On Amazon page, you have products that are similar to this page, right? It will recommend some similar products. Now, these similar products, there are many parts of the page. There are many parts of the page. For each part of the page, it would call a different service. It would call a different service and fetch the data. This web server will actually pull all of this data from various services and collate and build this whole final web page and send it back to the user. Now, this feature, which is similar products feature, requires a machine learning service, right? This requires a machine learning service, which means this could be residing on a completely different box. It need not be on your server, right? This could be on a completely different box where you have a model M, that is running here. And this server actually calls this service, this model. So this server, to fill up this place, to fill up this whole thing, what it would do is it would actually take the data. It would actually say, okay, I'm on so-and-so product page. I want you to tell me what are all the similar products. So it will send some information to the service, and this service would send back all of the related products, right? Through a recommendation engine, whatever model, right? So this whole thing is called the service-oriented architecture. Okay, there are also some extensions like microservices, etc. Again, service-oriented architecture is a very, very dense topic, very, very deep topic in software architecture design. I'm not going into the depths of it. But in a nutshell, for one of the very popular ways to deploy models is by saying, I have a box, the machine learning team has a box. On this box, my model M is running. Anybody can send me a request. Anybody can send me a request with some data. This data is basically your featureized input. Okay, I will respond back. So here I'll say, send in the request. I will respond back, sorry. Here I'll say, sorry, let me just undo this. Okay. Okay. So the way it will work is I have my request data here. The request data goes in and my response data here. So my machine learning model will now send a response. Right? So the request data would contain the feature vector, all the data that I need to recommend similar products. Like for example, in this case, my request data might contain the information about the user, the information about the product, right? And lots of other features. What this response will contain is basically a list of similar, it will basically contain a list of similar products. Now this machine learning and this request and response can come from any other box. I don't care. So this is my box. This is a server. This is a server that the let's call it a machine learning server. This is a server that the machine learning team runs, right? Anybody can give me a request with the features that I want, and I would respond back with a response. The good thing in this architecture is I can change the model without impacting the rest of the systems, right? So my server need not know, as long as there is an agreement on how to send the input and how to send the output, right? Think of your request as input to the model, your response as the output. As long as your machine learning server and your actual web server, this is your web server, which is serving the web page, right, to the customer, right? As long as they both agree on the format of this data, as long as they agree upon the input and output format, you can do anything in the back. So this is called a web API. Okay, these are in general called APIs, but web APIs are a popular method wherein I can send a request here to this box. So this is my machine learning server box where the machine learning model M is running, right? I would just send back. This is how it works. Now your question is, how do I build a web API? This is called an API, right? This is called a web API in a nutshell. Now again, I've skipped a lot of details. To be honest with you, I've skipped a lot of details about service-oriented architecture, microservices, APIs. I've skipped a lot of it. But this intuitive understanding is a good enough starting point, to be honest with you, right? Now the question here is, I have a model M, okay, that I've stored to disk here. Remember, I've already stored my model M to disk. Okay, let's assume it is stored in my machine learning server in the disk, my model file, right? My model file is here. Now, using my model file, I want to be able to have this service that anybody can call with a request, and I should be able to respond back with this. How do I build this now? So to build web APIs, there is a very nice tool called Flask in Python. So Flask is basically a library that helps you build web APIs in Python. Okay, I have not built some of these in R, so I'm not an expert there, but we have used some Flask-based Python libraries, right? And the best part about web APIs is the rest of your team, this service, your web server, they all could be writing code in a completely different language. For example, your web server may be writing code in Java or C++. Okay, some other service might write code in Perl. Some other service might write code in C++. It doesn't matter. Your service is independent of all other services. So you could write this whole code in Python or R. Okay, we'll see how Flask enables you to build a very simple web API. It's literally in 5 lines of code, you can build a very simple web API. I'll show you a very simple example here, right? So you can take your model file, and build a very, very simple web API in literally 5 to 10 lines of code. That's how simple and elegant it is, right? So let's go here. Okay. So just a second, please. Okay. I have some of these links that I have put in. Okay. So this is what a web API is. So API stand for Application Programming Interface. Okay. There's a Wikipedia page on what web APIs are. There are a bunch of protocols, there are things like that. So one very important thing is, suppose this is your web server. Suppose this is your web server. It is sending some data to your machine learning server. Let's assume this is your machine learning server, right? So it sends some data, right? It sends a request. It sends a request with all the data to the machine learning server. The machine learning server sends a response back. We just discussed this. But how does it send the data, right? So there is a format called as JSON, a very, very popular format which stands for JavaScript Object Notation. It's a very popular format to send data from one web server to other web servers. So typically these requests are not sent as CSVs or as tab separated values. This is typically encoded. Again, there are many variations to this, but typically JSON is the most popular format in which data is sent. Okay, your request and response, both of them are typically in something called as a JSON format, and JSON stands for JavaScript Object Notation. Okay, and it's very simple actually. JSON is a very simple thing. You laugh at it, right? So this is a very simple page on W3 Schools, and what JSON is. Suppose in a JSON you can represent an object like this, right? Here you have objects of type employees, and this is basically saying that it's an array. And in each array, you have first name equals to John, last name equals to Doe. So this is one way. This is a very simple text file in which you are sending 3 data points. All 3 data points are of type employees. And each employee has 2 fields or 2 features, first name and last name. In a machine learning case, the way it will work is you can send a JSON file. All right, you can send a JSON file and you can say my data point. Okay, you can say data point, and you can say my data point. Okay, my data point has feature 1, right? And feature 1 value is, let's say, 32. I have feature 2. Feature 2 value is 61, so on and so forth. That's it, you're done, right? This is basically this is how simple JSON is. If you want to send 10 features, you write each of the feature names and the feature values. An extremely simple form of writing it. And you can say, this is my data point type, right? So JSON is an extremely simple format in which data is often transferred or transferred between your web server and machine learning server. So I'll take you through a very simple code here, literally. This is a very nice resource that I found because I'll share, by the way, I'll share all of these links at the end of this discussion. I'll share it in the description section of the videos because we have to give the credit to all the great content creators who have created this content. And it's also beneficial to all of the students, right? So Flask is very simple. By the way, first, if you want to install Flask, just say pip install Flask. Or if you're using Python 3, just say pip3 install Flask. Single line, you can install Flask. Then, if you want to, so I'll explain you the simple snippet of code. Okay, there's a lot of code here, but I'll explain you the simplest thing to show you how simple the whole Flask thing is. You simply say from Flask, import Flask. You're importing Flask here, right? Here you're saying, I want to create a Flask object, right? And you're saying, so this is called a decorator. Don't worry too much about it right now. So here you're saying, if somebody calls hello, this function is called hello. This function returns hello world. Now, once I write this code, actually I've written this code if I'm not wrong. I've written this code here in my terminal. Okay, so I've written this code in a program called hello.py. Okay, and I've simply executed this. So if you notice, I've written this code in hello.py and I just executed saying Python 3 hello.py. As soon as I execute it, it starts a web server. So in computer networks, 127.0.0.1 basically means my local host or my box. So this basically implies my current box on which I am right now, right? So this is a standard in computer networks. So what it is doing here is on my box, this is my local host or my local box here. So its IP address is 127.0.0.1. It has a network port called 5000. Look at this. It has a network port called 5000. So on this network port, it is waiting for requests. It is waiting for requests from other boxes. As soon as a request comes, it actually executes the Python code and responds back. Okay, that's how web APIs work. You give a URL or an IP address, and you give a port number, and all of this is using the HTTP protocol that we use across the internet. Okay, HTTP protocol is what we use to load web pages, right? It's the same thing that we are doing here, right? So now if you go and check this, right? Suppose if I go to 127.0.0.1 5000, if I execute this, I get a hello world. Okay, just to be sure, let me open the tab again and run it again. You get a page saying hello world. So literally, what did I do with this 5 lines of code? Literally 5-6 lines of code. Anybody can now connect to my computer. What if my computer has some IP address? Anybody can connect to my computer using its IP address and using port 5000 and just send a request. This request is empty. It's not sending any information. It just requests on the 5000 IP address, on the port 5000. Okay, so now my computer will respond back with hello world because it's literally returning hello world. Now anybody can actually, if you know the IP address, if you know the public IP address of my computer, you can call it and get things back. Now this is a very simple introduction. Of course, this blog goes on to expand more on, actually this blog does a very good thing because it uses Python. So it uses model persistence that I was talking about, which is to store a model using the pickle module that we discussed. We discussed this extensively in the course, right? So we are using a pickle module to perform model persistence, which means we are storing this to disk. And now you can use this model, and literally your predict function is literally this much. Your whole code is literally this much to convert your model, or to make your model available through a web API. It is literally these 7 lines of code, right? So I'll share the link for this paper, for this blog, very well written blog, very similar to what we discussed. So as soon as you have Flask with just 7 to 10 lines of code, you can convert your model into a web API. Now, look at this. Now, your team runs this, any other team, because typically in a large company, there are many services that the web server calls to fill up this page. There could be one page about product ratings. There might be one service which does that. There might be other service which says who all are the sellers on this product page. Right? There are lots of these services that will be called. We are not bothered about all the rest of the services. We don't care about them. We are only worried about this machine learning service that we have, that we are responsible for. Right? Very simple stuff. And even writing this code, and other people can write code in Java, C++, I don't care. Right? Using simple Flask and just 7 to 10 lines of code, if I have a model, I can make this model available using web API. Right? So I think we are running short of time a little because we have almost finished with 1 hour, and I think there are lots of interesting questions. So this is an experiment. By the way, folks, this is a big experiment that we are conducting. Actually, this is the first live event we are conducting on YouTube, and that too a technical event, right? Till now, we have done some general live events on Facebook, mostly talking about the course or answering some of the students' questions about how to land machine learning jobs and things like that. Today, we thought, let's do a technical discussion, right, with some Q&A followed by that. And this is a big experiment for us also. So based on how students respond to this, based on the feedback that we get from the students, we could make this a more regular service or a more regular thing if there is a lot of excitement from the students, and or else we'll just drop this, right? This is an experiment. We want to interact with our students on more regular basis in this format. We also want to hear your feedback, your suggestions on how we can improve this, right? Again, this is a big experiment. We want to have a constant channel of discussion. So we thought that today we are discussing productionization and deployment of models. Maybe a week or two down the line, we could discuss other things, right? We can discuss like how to build a chatbot, Right? That's also a design task, right? What are the design challenges? How do you actually go about thinking and building a chatbot, right? Or how do you build a production ready self-driving car? What are the challenges there? Or how do you build a system like Alexa, right? So these are all very, very interesting things that we thought we could do it in this 90-minute format. It's a big experiment for us also. So let's see how the whole thing pans out. As I told you, it's a big experiment. And let's go back to the video section. Just give me a second. I'll just take a sip of water so that we can be back for the Q&A. Just a second, please. Okay, in the meantime, just put in your questions and our team is collating some of them. We'll try to answer as many as possible in the next 30 minutes. Okay, I'll stop the screencasting for a while. Okay, I'm back here. Sorry for this distraction. This is my microphone setup, just to ensure that you get better quality of audio. Okay, so let's go now. Where are we? So my team has been collating some of the most interesting questions and the most frequently asked questions. It's almost impossible to answer everything. Oh, wow, there are a ton of them. We'll try to answer as many as possible. Will the recording be available? So let me just zoom in so that all of you can see this. Of course, please understand that it's almost impossible for us to, let me just zoom in a little more, maybe 200%. Okay. So let's see, will the recording be available after this meeting? Certainly. What is the point if you don't share it with others? But we would encourage, see, we want this to be an interactive session with at least some questions that we take. I want this interaction to be built up because this is also a great way to keep our students motivated, right, through the course. This live session more frequently at regular intervals. Certainly some of these will be available, but we strongly recommend if you could join, right? We strongly encourage you to do this. Of course, some of you have suggested that we could do it over weekends. Certainly that's something that we'll take a poll and see what students prefer, because we are open to do it on any day, frankly speaking, at the convenience of the students. Yes, so these videos, if they turn out to be okay, if they turn out to be of good quality, we'll certainly add it to our course videos also. Again, as I told you, this is a big experiment that we're doing. We still don't know if the whole thing works out. So frankly speaking, it's a big experiment, right? So the next question is, I hope, what's the view now? I think you're seeing me, right? Okay, so let me just screencast just so that you can also see the questions. Okay, at least some of the questions that we will try and answer today. Okay, so include chatbot deployment process. Very, very good question. We would certainly try to do that. Actually, we were thinking of doing how to actually design. So one thing that we notice is while many students know the techniques, many students know what is logistic regression, what is GBDT, what is deep learning, what is RNN, what is CNN. Most of them falter when they're given a real world problem. Suppose if I tell you, design a chatbot. You claim that you know machine learning, deep learning, design a chatbot. Most students are lost there because they don't know where to start. They don't know how to take this problem and break it down into smaller pieces and understand how to think about it. So what we try to do in this exercise is we try to show you the deployment of models or productionization of models is a big task. It takes months sometimes, to be honest with you, right? We've had instances where I spent months, I have the model ready, but just to get the whole thing in place took us months, right? So it's important to understand what are all the components, what are all the opportunities, challenges, risks, right? So we would certainly discuss, we are very excited to talk about, because a lot of people have this misconception about chatbots, right? So there are multiple types of chatbots, some of them simple information retrieval stuff, and there's a lot of hype around chatbots, right? So we wanted to tell you what are all the design choices, everything from data sets, what models might work, right? That's something that we want to do, not just for chatbots, but for the wide spectrum of things. As far as chatbot deployment itself is concerned, you could still do it using the web API method that we just discussed. It's a very popular technique that a lot of chatbots actually use, right? So as far as the deployment process of chatbots is concerned, web APIs is still the popular method. But the bigger challenge is, how do you design a chatbot? Maybe you could be working for a bank, right? What are the risks? What are the requirements using which you would design the chatbot? Or you could be working for a customer service aspect of, let's say, an e-commerce company. How do chatbots help there? Okay, so general purpose chatbots never work. Okay, companies like Google, Facebook, Microsoft tried and failed, and they have humongous amounts of resources. So it's something that we want to discuss, and we'll surely take it up as one of the tasks over the next few sessions. If sessions like this are interesting to students, we would certainly love to do more of them. If the participation is also encouraging to us, we would certainly do many more of these. Chatbot is something that we will certainly be one of the first things that we would do. Right? So the next question is, what to do if there are new values in a feature that are not present during training process, let's say categorical features. Okay. So what you're saying here is, let's assume there's a categorical feature F. So let me write it down here. So let's assume there is a categorical feature FC. Let's assume it has values C1, C2, C3 in the training data. But in the test data, we also see C4, right? In that case, right? So if you're doing one hot encoding, right? If you're doing one hot encoding, this FC will be encoded as C1, C2, C3, right? One of them will be set to 1, right? If C4 is present, you would set all of them to 0. Depends on the encoding. So if you're using one hot encoding, you would set all 3 of them to 0, right? This is one hot encoding. Again, we discussed this in the course in a lot of detail. On the other hand, if you're doing response coding, right? If you're doing response coding, so response coding basically means wherever there is a value of C1 for feature C, you would actually use probability of yi equals to 1 given fc equals to C1. Right? This is what response coding is. Again, I'm assuming that things are binary valued here, that your class labels are binary valued. So in the case of response coding, you have never seen C4, right? So you would just use probability of yi equals to 1 without any condition here, right? Whenever you have C4, right? So again, it depends on the encoding. For one hot encoding, you would leave everything to zeros. In response coding, you would just use probability of yi equals to 1, which is if you have a balanced data set, this is close to 0.5, right? So these are some of the ways that we do it. And I think we have done this in some of the case studies also. Okay, having said that, next question. What to do if there are, how to extract text from PDF using deep learning, probably CNN. So if you want, again, depends on what does extraction here mean. This is a very interesting real world problem. Is your text in a specific location of your PDF file always? Let's assume your PDF file is an application form. All of your PDFs are application forms for, let's say, some examination. Then you know where is the exact text, right? You know where exactly the text fields are. You know where the name is, you know where the address is, you know exactly where it is. So typically for a problem like this, right? For a problem like this, we typically end up using RCNNs, right? Which are a combination of RNNs and CNNs, right? Because when you're extracting a sequence of words, suppose if I'm extracting this, CNNs are very good at your OCR or object character your character recognition, optical character recognition, not object character recognition, sorry, right? So if you give it F, if you give something like this, it's very good at recognizing that it's F, even if it's a handwritten character. But now you have a sequence of characters, right? So very popular technique is an RCNN here. And again, it depends on the problem. If you have free form text, no formatting, nothing, then getting a highly accurate conversion from image to text, right, is harder. But if your data is PDF, right, PDF to text, you don't have to do all this CNN. So all of these are useful if you have image to text, right? You have an image and you're trying to convert it to text. From PDF to text, because PDF is a standard format. PDF is a world standard format, right? So you can just take the PDF format that you have and convert it into text using tons of other, like simple software engineering, simple software tools. You don't have to use deep learning, all of that. Sorry, I missed this part in the earlier section. If you have image to text, RCNNs are useful. But PDF to text, there are lots of simple software, non-machine learning stuff that you can use, right? So, okay, so the next question is the same as the previous one, right? Okay. Okay, yes, the third and fifth are the same. Okay, I'll just ignore this. How to use AWS SageMaker for deployment? That's a good question. So AWS SageMaker is a cloud-based tool. So whatever we have done, right? So imagine this whole pipeline that we have, this whole pipeline going from raw data to processing to featureizing, all of this can be done in a single tool called AWS SageMaker. This is part of Amazon's Web Services. So this is very useful. This is extremely useful if all of your data lies on Amazon Web Services, and if you're using Amazon Web Services for your computer resources. Again, you should use this. So the question here is when to use. You should use AWS SageMaker for deployment if most of your data, let's assume all of your data is in S3, right? Amazon S3, which is the simple storage service. And if you're using, let's say, AWS for all of your compute resources, right? Your EC2, Elastic Compute Cloud. So if your data is stored in S3, if you're using EC2 for all of your Amazon, for all of your compute resources, it makes a lot of sense to use SageMaker, because SageMaker can read data from your S3 and it can use EC2, all of that very well. So if your company is already using Amazon Web Services extensively, using SageMaker makes a lot of sense, right? Again, internally, SageMaker gives you an API-based framework, okay, to train and deploy models. Internally, what SageMaker is doing is using something like Flask, okay? How things change when you're working in a cloud environment, as I was just referring to earlier. In cloud environments, there is an equivalent for everything. For example, your raw data. Let me give an example of Amazon, which I know slightly better than other cloud platforms. Your raw data is stored in something called as simple storage service. Okay, if it's a raw text file or CSV file, there are databases, right, on Amazon Web Services. There is a Hadoop cluster. All of them are the same thing. The pieces stay the same. So for this ETL process, there is something called as simple, it's called SQS or SNS. There's so many services that I forget them, right? You can actually do this whole ETL process itself. There is a pipeline management software within Amazon Web Service. I think it's called simple notification service. No, it's not a notification service. There is one of those simple sum service which lets you orchestrate all of these ETL queries in a sequence and get featureized data. This featureized data, you would store it in S3 again. And once you store it, you train this model. If you're using a Spark cluster, you can get a Spark ML instance on top of EC2, right? The same story. If you're using sklearn, again, you'll take a box on EC2, which is the Elastic Compute Cloud that Amazon has, and install some of these tools. Now, again, the same story. As far as this deployment is concerned, you could write your own Flask-based APIs, or you could use things like SageMaker. The components don't change. The core components that we just discussed do not change here, right? The only thing that changes is how the specific cloud, whether it's Google Compute Cloud or Microsoft Azure Cloud or AWS, how they have implemented it. So this is a very good question. Do data scientists need to have knowledge of Hadoop, Hives, Pig, and Spark? Very, very good question. This depends a lot on the team. So let me give an example. So my team was one of the earliest adopters of Spark, Hadoop, and many of these things. But we never interviewed people on these, because we felt that if somebody knows basics of programming and basics of machine learning, so for data scientists, there is no Spark, Hadoop, Pig, Hive type of interviews. Because we have hired people who don't know what is Pig. They think Pig is the animal, not a software tool that can be used on Hadoop. Okay. But what we've seen is if you get a good data scientist who also knows some programming, they can easily pick up these things. So what we used to do, so we never, at least in my team and in many teams that I know at Amazon and other good product-based companies, of course, knowing them is never bad. Okay, if you know them, that's great. There is no need. But if you know them, you certainly have an advantage. There is no doubt about that. But not knowing them, you're not at a disadvantage. Because if you know all of them, but if you don't know basics of logistic regression, gradient boosted decision trees, and deep learning, nobody will give you a job of a data scientist. Okay, so these are not mandatory skills, Because I learned, because in most of the interviews that I've done at most of the companies myself, both at Yahoo Research, Yahoo Labs, and Amazon, I was never asked these questions, even though I knew some of them. I was asked questions on data science, mathematics, and software and programming, right? And after I went in, of course, these are stuff that we would use every day. Even if you don't know, you can pick these things up in a month or so, right? So the next question. So please let us know about model persistence of different algorithms. If you're using PySpark, sorry, if you're using Python, like something like scikit-learn, right? You can persist the model irrespective of what the algorithm is. Irrespective of what the algorithm is, you can persist the model to disk, right? Using your, what is that library called? Very popular library. We just discussed about it a while ago, right? I forgot. Just give me a second. Let me refresh my memory here. Okay, so you can do it using using the pickle library here, right? So you don't have to worry about what algorithm you are persisting as long as you are using pickle. So pickle is not sklearn specific. Pickle is Python specific, right? Any model you can persist if you're using scikit-learn through pickle. But if you don't want to persist this way, for example, if you want to store the parameters of the model, for logistic regression, it will be weight and the bias terms. For, again, it depends on the model to model, right? For example, if it's, see, what are the parameters of the model, right? If you're using decision trees, you can store a decision tree as a bunch of if-else conditions. We have discussed this extensively in the course, right? So if you're storing an SVM, all you need is support vectors. If it's a non-linear SVM, all you need to store is the support vectors, because if you have the support vectors, you can compute the kernels on top of the support vectors. Of course, you need support vectors and the parameters of the kernel, right? If you store them, you can rebuild the whole SVM itself, right? So, but as far as model persistence is concerned itself, you can do it using pickle in Python. I'm sure there are equivalent stuff in Java, Scala, etc. Please let us know about web scraping to extract data. So web scraping is basically a bunch of libraries. Like Python is a very popular tool. There are also web scraping tools in Java. You can basically obtain, so one very nice tool is called Selenium, right? Selenium is a tool that is used mostly for testing, but you can use Selenium, you can write code in Java or in Python using Selenium, and it literally get the whole page for you. Then it's a bunch of regexes. Then it's a bunch of regular expressions that we have discussed in the course, right? So you just obtain the whole web page itself, and then you apply a bunch of regular expressions to scrape all the parts of the page that you want. But please be warned that a lot of companies don't want their websites to be scraped, okay? Because they think that their data is very, very valuable to them. So companies will block you. Okay, please. So there is a file called robots.txt for most major web pages. Please read this page and respect the terms in robots.txt. Please don't just go ahead and scrape the pages without the permission from the website owner. That's illegal. Okay, I'm being very, very strict here. Please don't do that. So whatever you're scraping, please use the right number of requests, because you don't want to bring down a web server by just scraping. Right? So Selenium is a very good platform if you want to scrape web pages. Okay, I'll try to go down as many questions as I can. How do I parallelly predict multiple images at the same time? How do I predict parallel? What do you mean predict multiple images at the same time? Oh, I think, okay. So, okay, I think, okay, so what the question here is, you are, instead of one request and one response, right? You want multiple requests response. So I might send more than one image. You can do that, right? In the request, instead of sending one image, you can send a sequence of images. The response could also be a sequence. That's one way of doing it. Okay. And you could run one model in each core of your box. Let's assume your box is 4 core. Let's assume your box is 4 core. You can run each of these models, one model on the first core, second model on the second core, third model on third core, fourth model on fourth core, right? And these, of course, there is some engineering hacks that you need to do to ensure that these requests go to one of these cores. You require something called an operating system synchronization thing that you need to work around, but it's possible. Okay, that's one thing. The other thing that people do is they have multiple boxes. They have multiple boxes, and they have something called as a load balancer. We also touched upon this in the course. You send many images. It will send one image to this, one image to this, one image to this. It will get these responses and send you back, right? So this could be either a multi-core system or a multi-box system, right? Both of them are possible, right? So a role of Kubernetes in deploying ML models. Frankly speaking, I'm not an expert at Kubernetes. I don't claim to be one, but I've seen a few teams that use Kubernetes in machine learning model deployment. But frankly speaking, I'm not an expert, so I don't want to comment on it without reading a little more. So I'll avoid this. Having said that, when to use AWS EMR for deployment? By the way, EMR is basically your Elastic MapReduce. Elastic MapReduce is basically a platform where Amazon gives you Hadoop and Spark. Okay, so basically what EMR gives you is basically Hadoop and Spark on the Amazon clusters, right? So here, if you want to, if you have a lot of data, okay, let's go back here. So if you have a lot of data in your Hadoop or Spark, if your data is in Amazon S3, see, you should use AWS. All AWS tools are more valuable if your data is stored on AWS cloud. Then instead of you setting up your own, see, the value proposition that EMR brings is, instead of you using EC2 clusters, installing Hadoop and Spark and doing all this headache yourself, AWS EMR gives you default Hadoop, and you can just say, I want 30 boxes Spark cluster, each one with so much RAM, each one with so much disk space. EMR will just give you that cluster in 5 minutes, instead of you having to maintain, deploy, etc. So if your data is on EC2, sorry, if your data is on S3, instead of using EC2 boxes, your models for using Hadoop, for installing Hadoop and Spark, it's best to use AWS EMR. For those of you who don't know AWS and all of this stuff, don't worry about it, right? This is something that I learned much later. Very important, right? I didn't know anything. I don't know even ABCD of cloud computing or Amazon Web Services before I joined Amazon. And I was already like 3-4 years experience then, right? For a machine learning role, data science, machine learning, mathematics, and programming are important. Cloud computing, you will pick it up as and when needed. I picked up all of these things. For example, I didn't pick up Kubernetes till now, because I didn't get into an instance. That's why I'm not an expert in it. All of these AWS services, I've used them or I've interacted with those teams, and hence I learned. What is the significance of running ETL? You need to run ETL to get your models, to get your data, right? Without the ETL pipeline, you don't get your featureized data, which means you don't get your model. At what frequency should you do it? That depends. As I was referring to earlier, you should do it at least at the frequency at which you're training a model. If you're training your model once every day, you should ideally run your ETL once a day, or maybe much more frequently, so that all the data is available. See, with the ETL, you're getting featureized data, right? At the end of ETL, you're getting featureized data, which you need for models, right? So if you're going to train your model every day, you need to run your ETL every day without a problem. Does it improve my model? No, it doesn't improve your model. ETL is a necessary step to get the data into the model. Without that, you don't have data, especially if your data is in a data warehouse or a Hadoop cluster or a Spark cluster, or if it's on let's say a database, right? How to train a model with combination of multiple machine learnings to build a solution. We have discussed this extensively in the course. So we have things like stacking. So go back to the course, or if you're not a participant of the course, that's still okay. There is something called as model stacking. There is also bagging and boosting, right? But in bagging and boosting, we typically use the same type of model, but with different parameters every time, or different data sets. Stacking is what you're looking at, right? Using stacking, you can combine multiple models to build a better solution. And this is what a lot of Kaggle competition participants use, right? So can we run ETL pipeline in real time instead of hours or minutes? Very good question. So this is the engineering challenge, right? So there are platforms that enable you to do ETL pipelines in real time, or almost real time. building this from scratch. So there is something called as streaming. There is something called as a streaming data, right? Which means you're getting the data live and you process this data in live, and you then featureize this data and train your model in real time. Okay, that's called the streaming pipeline. There are some platforms like Storm, which were very popular at some point of time. But actually, my team, we tried to use Storm for a while, but then we said, we built this ETL pipeline in real time ourselves. So our engineer, we had a terrific engineering team, a brilliant bunch of engineers, right? We built an ETL pipeline in real time because we had a requirement to be able to analyze data. And this was like petabyte scale data sets. You want like, it's massive amount of data. So we built an ETL pipeline in real time to process this. But I believe there are some, because we tried Storm, it didn't work for our needs. So we ended up building our own stuff. So there are instances where this is useful, but not always. Sometimes running ETL in real time is an overkill. If you don't need this in real time, please don't do it, because it can get very, very expensive, right? So in our instance, we needed it because of some constraints that I cannot discuss further because it's a sensitive topic. Okay. Okay, so where are we? During the deployment of machine learning models on production, do we use sklearn libraries where we have real-time data? Yeah, so we can use sklearn libraries. The model that you have, right? The model that you have persisted is basically an sklearn model, right? Now, using this model, you're building a Flask API on top of this. So it's the same Python code that is running, but you've put a Flask layer on top of it so that this becomes a web API, right? It's the same thing. So on your box, you need to have scikit-learn installed, all of that stuff. Otherwise, your model can't run, right? So whatever box you have, whatever machine learning server you have, right? You have your model here. This model will be executed. You need to have scikit-learn installed, all the libraries installed. Otherwise, this model cannot be executed, even though this is put inside a Flask, right? Flask is just giving you a web API to this so that other computers can talk to this computer, right? So what is the other part? How do we use our own logs and advancements and hacks? You don't have to worry about your own logs and your own hacks. Scikit enables you to do that very easily. The web page that I was referring to earlier, there is a very detailed description on how to use a persisted model. Just in the interest of time, I didn't go too deep into it. I'll share the reference link at the end of this discussion. Please go through it and you would understand some more details, right? This is a fun thing. Which is the best cloud deployment? Azure, GCP, AWS, or IBM? I've not used all of them. I've used AWS to some extent. So I don't think I'm an expert to comment on this because I've not used all of them. But my suggestion is simple. All of them give you some basic tools for ML deployment and productionization. So it all depends on where your data is. If your data is on AWS, you should use AWS. If your data is on Microsoft Cloud, you should use Azure. If your data is on the Google Cloud, you should use GCP. There is no point moving your data from one cloud to other cloud. If your data is on IBM Cloud, just use the ML deployment that is available in these cloud platforms, right? But I'm not an expert in this. I have used AWS extensively. In many instances, I have built I mean my team. We have built the deployment platform from scratch ourselves. That's what we have done extensively. So I'm not an expert in the other stuff, so I don't want to comment. But in a nutshell, the rule of thumb is wherever your data is, just use that. Even if, let's assume, I don't know this, let's assume IBM does not have a very good deployment platform. That's okay. You have Flask, you have Python, you have all these tools that you can install and make a very solid machine learning deployment platform using IBM. What is stopping you? Nothing, right? Okay. How do we pass images to Keras models? Okay, so Keras, yeah, so this, if you're trying to do multi-threading, Keras can run into issues. That's primarily because the way Keras works is if you have a GPU or even in a simple non-GPU setting, there is a problem here. So I'll have to think a little more on how to do this. But one thing, especially if you require a lot of parallelization, there is always this option that you use multiple boxes and you put a load balancer in front of them. You send all the images, right? And each of them goes to one box. If you want answers very fast, or else why don't you process each of them one after the other? If you require, I'm not sure because I've never tried multi-threading or multi-core on Keras. I've not done that myself, but I've done this load balancer type of setup for a distributed Keras type of stuff. That works. This I need to look into it, and as you mentioned, it gives compatibility errors. Just Google search if people have done this, maybe on a non-GPU setup. And I know that this can be done if you have multiple GPUs on your box. So if you have a box with, let's say, 4 GPUs, I can send each of these images to each of the GPUs. So that's a multi-GPU, but I don't know multi-threaded. I've never tried that myself. Okay, so just Google search, maybe there is something that I don't know that it's still possible. Should we learn about Firebase machine learning kit in creating apps for machine learning? So I don't know Firebase machine learning kit myself, to be honest with you. I've heard about it, but at the end of the day, right? Of course, if Firebase makes your life simple, certainly do it, right? But at the end of the day, even if Firebase doesn't suit your requirements, you can just use the so let me just see what Firebase is anyway. What is Firebase kit? I think I've heard of this. Firebase kit. What does it do? Just give me a second. ML kit for Firebase for mobile developers. Oh, okay. Oh, is this a Google one? Yes. Okay. That's what. Okay. Got it. Oh, yes. So thanks. Okay. I've read about it. I just forgot the name. I was confusing it with something else. So yes, if you're doing mobile applications, Firebase probably is one of the really good ones. There is also other ones like you have TensorFlow. You have TensorFlow that you can run on mobile phones now, especially for deep learning applications. And I'm sure since Google is building it, Firebase should be a very high quality because I trust Google to build good products. So if you're doing, I've not used Firebase, to be honest with you. I've not at all used it. I've used TensorFlow on mobile phones, but Firebase, since it looks very good, it's a beta product, so just be a little careful to test your stuff well, but seems like a good product. Okay, so where were we? To perform, okay, distributed deep learning, TensorFlow has distributed deep learning for you. So can do, even Keras to some extent. TensorFlow and Keras can do distributed deep learning. Basically, distributed deep learning basically means instead of one GPU, you are using multiple GPUs to train a model. These GPUs could be in a single box, or they could be across multiple boxes. The moment you have data across multiple boxes, moving the data from one box to other box becomes a big headache. But TensorFlow and Keras were designed. Actually, Google uses TensorFlow itself for most of the distributed deep learning. So there's a lot of documentation on TensorFlow on how to make it work, even Keras, on how to make it work when you have multiple GPUs or GPUs spread across multiple boxes. Okay, how MLlib, so what is the use case to transform data from one box to another box on Spark? Data. If you have 10 terabytes of data or many terabytes of data that you cannot store on a single box, go to Spark. How MLlib is different from scikit-learn? Scikit-learn trains models and performs everything on a single box. This is a single box implementation of each of your algorithms. MLlib, the Spark MLlib, right? Spark MLlib implements all of your algorithms on distributed data, right? As we discussed, right? So your Spark ML, this is how your data is distributed. Your models are trained in a distributed fashion. If you train logistic regression using Spark, the logistic regression model is trained on the data using the CPU and RAM of each of these boxes, right? So MLlib is, so there's a whole area called distributed machine learning, and MLlib implements most of those distributed machine learning algorithms for you without you having to worry. Okay, I think there's still a flood of questions. We are still running short of time. Just not to bore you, we'll stop it here. So we have answered 23 questions, which is a good track record. I thought I'll answer only 5 or 6 of them. And it's good. It's fun to answer these questions. And most importantly, we want to hear your feedback on this experiment that we're doing. Okay, let me stop the broadcast. No, let me stop the screen sharing so that I can make. So what we're doing here is, it's a big experiment that we're doing. We also don't know if this format is interesting to students, how students think about it and things like that. So it's an experiment that we're conducting. We want to hear your feedback, what you think of this. if we take up topics like these, like how to design a chatbot, how to train a fun. We also wanted to have some interaction, right? Imagine if I just did this video, 1 hour video, and posted it to YouTube. There is no back and forth, the way we had with Q&A, right? So that's why we thought a live session also makes it more regular. Of course, we could do it at a time that most of you are available and convenient with. But in a nutshell, what we're trying to achieve here is trying to create a channel of discussion, technical discussion, right? Not just about the course, but about technical topics. That's why if you saw, I even gave options for R, because there are some students who are not part of our course whom we still want to benefit as part of this exercise, right? So all in all, please give us feedback. Also tell us what you think about this new format in the comment section. Give us feedback on how we can improve, right? That's something that's beneficial both for our students and for us. It's when we all work together with some good, interesting, critical, and valuable feedback that we all grow. Okay, folks, I'll have to take leave. We are already 94 minutes into this discussion. Thank you for joining. There are hundreds of students who have joined. Extremely happy with the initial response. Would love to hear more from you. Have a good evening and good night.